Hi, I'm Paul with SparkFun Engineering, and this is another edition of Engineering Roundtable. This week I'm going to be showing you a little bit about what I do here internally at SparkFun. Occasionally, my fellow employees will come to me needing devices built to make their jobs easier.
35, 36, 37, 38.
You guys seen the new Limp Bizkit video?
No!
Let's go watch it.
All right, cool. that was good, man. Thanks. I lost count. Gee whiz, there's got to be a better way.
So this week we're going to be talking about kitting and the machine that takes these jumbo rolls of conductive thread and spools it down onto little 50-foot cardboard spools for you, the customer. So let's have a look at the machine. So this is the Spoolmaster 9000, latest and greatest in spooling technology. So I'll give you a quick rundown of how it works, and then we'll go through part by part and see how it all functions together. To start with, I designed these 5-inch cardboard spools. We cut them out in-house on the laser. These spools go into these holders, which I drew in Creo Parametric and then had 3D printed. So they hold the spool. The cardboard holders are then turned by these 2 stepper motors turning against each other, which makes it spin the same direction. The user interface is really simple. You load in the bobbin, hit the reset button to reposition the feeder servo, and then hit go. This will make the bobbin spin 60 times, which 60 times 5 inches will give you 50 feet of thread. There's also a speed knob on here to make it spin slower or faster, naturally. And of course, the emergency stop for when the thread gets all tangled, or if your rat tail gets caught in there, if you were to have one. So here is the first stage of the process. We have the spool propped up to allow the thread to wind off very easily, thus not jamming. So here we have the second step of the process. This is the tensioning mechanism. These flexible arms allow the user to position the eyelets wherever they need to be to apply just the right amount of tension, which is critical for proper spooling. So down here, this servo evenly distributes the thread across the bobbin. Down here on this side is the Hall effect sensor, and there's 2 magnets on here. That's what keeps track of all the counting. Let's pop this open and have a look and see what's inside. So there's 2 motor drivers, 1 for each stepper, and 2 Arduinos. One that keeps track of the count and one that drives the motors. I did this so that the user can easily stop the motors and not worry about losing count. I know I could have done this in the code, but I would just as soon keep them totally separate so there's no chance that you have to hit the E-stop and lose track of your count and start over. Well, that's all for this week. Thanks for watching. I'll post all the board files and design files on the site. If you have any questions, don't hesitate to post, and check back again in 2 weeks for the next episode of Engineering Roundtable.